All right, so I know it's not ideal. I apologize for not being able to be at school at the first day of the trimester, but a lot of you I've had in class already. We'll catch up on everything tomorrow. I'm not super worried about it. Today, you are going to get started with lesson 8.1. You should have gotten the note sheet from Miss Jen, so you can fill that out as I go through these. If you need to pause the video to get them filled out, if I go a little too quick, then don't hesitate to just pause it and get those blanks filled in. But you should be filling this in with me. If I'm looking at your notes, we're starting right here. You've got a couple blanks on it. A quadratic function. Oh, I should probably say this. 8.1 is graphing y equals ax squared. Okay, so you're used to your whole career of graphing lines. Now we're looking at graphing, which would be like y equals x, or mx plus b, your favorite thing ever. Now we're looking at graphing something that is x to the second power. When x is to the second power, that's called a quadratic function. Like it says, it's nonlinear. It's not a line. It's a U-shaped graph. When it's written in standard form, which we've seen before, it would be a times x squared plus b times x plus c, which if I had you last trimester, I talked about this form just a little bit, so it should be kind of familiar. What we're really doing is taking some things that we factored last trimester, and we're going to look at graphing them. The equation is called a quadratic. The graph, that is the u, is called a parabola. Now, today, we're not graphing all these pieces. We're only going to graph things that have an a and an x squared. So there's this other stuff going on, but we're just going to kind of ignore that for today and build on ax squared. A function in its most basic form is called a parent function. That's what this is talking about right here. In its most basic form, here's what this U-shaped graph looks like. Right here. Notice it's right at 0, 0, and we would say that the slope, it's not called a slope, but like the steepness of this is normal. It's just a 1 in front of the a, so it's a normal steepness. Now, like it says over here, a key point. The vertex is the highest or the lowest point. In this case, the vertex is the lowest point. The axis of symmetry is a line. It's an x equals line that splits our parabola in half. So you can see here, it's right on the y-axis in this case. There's this dotted line. That's our axis of symmetry. It's splitting our parabola in half. If I were to hold a mirror up right here, I'd be able to see, and just look at this side, I'd be able to see both sides because the axis of symmetry mirrors the parabola. So let's look at some examples of this. We've got, looks like 3 of them here to look at, that are all on your note sheet. Now, let's get this labeled. The vertex looks like it's left 1 and down 2, so that would be at -1, 2. The axis of symmetry is the line that splits our parabola in half, all of this. So that is the equation, x equals -1. The domain, remember domain is talking about our possible x values. It's our favorite domain ever, all real numbers. Our range is talking about our possible y values. Well, our smallest y value, oh, our vertex is at -2. There we go. Our smallest y value is down here at -2, and our parabola is facing up. So we're looking at, oh, not x, we're looking at what the y's are doing. The lowest one is -2, and we want everything above. Well, everything above would be everything greater than. Now, this idea of increasing and decreasing can be a little bit tricky. If I were to plant you inside this math problem right here, we would be increasing anywhere, and you had to get, let's say to get to this other side, okay? Anywhere that we would be running downhill, we would be decreasing. Anywhere that we would be running uphill, we would be increasing. So how do I list that blue part? And this is tricky, so stay with me. I list that blue part, that's the decreasing, by saying that's where x is less than negative 1. The left-hand side of my vertex, the left-hand side is decreasing. The right-hand side would be increasing. That's why I'm running up the hill. So I'd say that's where x is greater than negative 1. We'll continue to work on increasing, decreasing. That's one of the trickier things from this lesson, but do the best that you can on it for right now. You're good. All right, so again, we'll go through more examples, but let's keep going. Now, where this gets, let me just look ahead here a second. Yeah, okay. Where this gets interesting is when they put a number in front of this a value. Like it says right here, when a is between 0 and 1, then the graph is going to get wider. So like if this is my parent function here, if I had a fraction in front between 0 and 1, like 1/2 x squared, then that's going to make it so my graph is wider like this. It takes longer for it to grow. But let's say I had a number like 2 in front. Well, that multiplying by 2 is going to make my graph grow quicker. So it would look more like that. Now, if we throw a negative in with it, here, if we put a negative out in front, now that flips our graph over as well. So let's say I had a negative 2. Well, now it's going to be skinny and it's going to be flipped over. So let's sketch this graph and see how we do. We have a negative 2. Oh, negative 2, look at that. If our parent function, let's say, looks like this, just like a normal, a negative 2 out in front would be like this. The negative makes it flip, the 2 makes it skinny, or vertical stretch. We've used that language before. Our vertex here is at 0, 0. Our axis of symmetry is x equals 0. If we were to compare, we've used this language before, we'd say reflection over the x, well, not 2 commas, over the x, and we would say vertical stretch of 2. Our domain is our favorite domain. It's all real numbers. Our highest y is 0, and it's everything below it. So we'd say y is less than or equal to 0. Now, on the yellow graph, I would first start to climb up the hill, and then I would start to run down the hill. So if I want to say I'm increasing, that's where I'm climbing up. That would be to the left side. So I'd say x is less than 0. That's be where I'm increasing. If I want to say I'm decreasing, I'd say x is greater than 0. That would be this right-hand side. Let's take a look at one more example. Now we have a 1/3 in front of the x squared. Well, if we said anything between 0 and 1 is going to make our parabola wider. So if this is my normal, or my parent, let's say I have a 1/3, that's going to make it wider like this, wider like that. My vertex is still at 0, 0. My axis of symmetry, the line that splits it in half, is right in the middle at 0, 0. Compare, I would say now that this is a vertical shrink of 1/3. My domain is my favorite domain. My range, I've got y, my lowest y value is 0. I want everything greater than or equal to. If I were to drop you into here, and let's say you had to run to this other side, you would first be running downhill, and then you would be running uphill. Wherever we're running down, that would mean we are decreasing. When x is less than 0, this spot is at 0, 0. When we're to the left of it, we are decreasing. And when x is greater than 0, when we are to the right of it, we are increasing. So that's a quick version of this stuff. We'll continue to revisit it throughout the week. But now you don't have just this assignment to do. You got to go to campus to see. You got a couple other things that you need to look at.